In this video, we will be discussing how to calculate the area of a regular polygon. But before we talk about that, let's talk about what a regular polygon is. A regular polygon is a polygon that has all sides and angles congruent. So all the sides are congruent and all the angles are congruent to each other. So if we think about an equilateral triangle, all the sides are congruent in an equilateral triangle and all the angles are congruent in an equilateral triangle. Now this is a special type of regular polygon, so there's actually a formula that we can use to calculate it if we know the side of an equilateral triangle. So first I'm going to derive this formula for you because I want you to see where it comes from. Again, you will not be responsible for being able to derive it. I just want to show you where it comes from. So let's say we have this equilateral triangle and we know the side. We're going to call the side S. So since all the sides are congruent, each side is going to be S. And then normally when we're calculating the area of a triangle, we need to find the height of that triangle. Now, since all the angles in an equilateral triangle are congruent, we know all the angles in a triangle add up to 180. So 180 divided by 3 is 60 degrees. So each angle in this equilateral triangle is 60 degrees. Now, if I draw in that height, it will bisect that top angle and make both of those angles 30 degrees. So notice that when I draw the height of an equilateral triangle, I have two 30, 60, 90 right triangles. Now since the base is also equal to S, when I draw that altitude, that's also going to become a median. So now each of the pieces of the base is divided in half. So that would be 1/2 S, 1/2 S. Now, to find the height in terms of S, I know that in a 30, 60, 90 triangle, the side across from the 30 is equal to X. The side across from the 60 is equal to X square root 3. So if I take 1/2 S and I multiply that by the square root of 3, I can write that as the square root of 3 over 2 S. And that's the height. Now, using our triangle formula, we know the area of a triangle is equal to the base times the height divided by 2. So the base is equal to 1S, the height is equal to the square root of 3 over 2S, and then all of that is divided by 2. Now, if I were to clean up that formula, I know that S times S is equal to S squared, and then I have the square root of 3, and that's all over 2, and then if I divide that by 2 again, I get 4 on the bottom. So this is our formula for calculating the area of an equilateral triangle if we are given the side. This is a much quicker method than using 1/2 base times height to calculate the area because you'd have to figure out the 30, 60, 90 and you'd have to kind of calculate out that height using what you know about a 30, 60, 90 triangle. So this will save you some time. So if you're given the side of an equilateral triangle, you take the side, you square it, and then you multiply it by the square root of 3 and divide that by 4. So we'll get to some examples a little bit later, but just keep that formula in mind as another way to prove the area of an equilateral triangle. Another way to calculate the area of an equilateral triangle. Okay, so now let's just talk about the area of regular polygons in general. To calculate the area of a regular polygon, you're going to need to know a few things. So each regular polygon has a center point, just like in a circle. It also has a radius, and the radius is drawn from the center point to one of the vertices of the regular polygon. So in this case, I have a regular hexagon, but this goes for any regular polygon. So we have a radius, and then if I were to drop a segment perpendicular to the side of my polygon from the center point, this is known as our apothem of our regular polygon. So it's the distance from the center to the side, the perpendicular distance from the center point to the side of our regular polygon. So to calculate the area of any regular polygon, I take the length of the apothem, I multiply it by the perimeter of the polygon, and then divide that by 2. So A is equal to the length of the apothem, and P is equal to the perimeter. So keep this formula in mind because we will be using it for our examples in just a minute. But first I want to reflect on what are some types of regular polygons that we can use this formula on. So even though we just found a formula to calculate the area of an equilateral triangle, we know that's a regular polygon, so we can use that on this formula. Now if we think about our four-sided polygons, we've talked about what's the four-sided polygon that has all the sides and all the angles congruent. That would be our square. Square is our equilateral quadrilateral. Now from that point forward, we can use it on a regular pentagon. So there's not really fancy names for the rest of them. We just put the word regular in front, and that's how we know that all the sides and all the angles are congruent. So regular pentagon, regular hexagon, and so on. Those are probably the four main ones that we will be using it on, are the regular pentagon, regular hexagon, square, equilateral triangle. Now you can use it on any type of regular polygon, but those are the four that we'll be working with primarily in this class. One thing I want you to keep in mind is if we draw our regular three-sided figure or equilateral triangle, and then we draw that center point, when I draw the apothem and the radius of a equilateral triangle, keep in mind since all the angles in an equilateral triangle are 60, once I draw in that triangle, I get a 30, 60, 90 right triangle. So you have to keep that in mind when you're trying to find the apothem or you're trying to find the side of an equilateral triangle. For a square, if I draw a square and the center point, and then I connect the apothem and the radius, since all the sides of a square, or all the angles of a square are 90 degrees, this would become a 45, 45, 90 right triangle. Regular pentagon doesn't have a special type of right triangle, but a regular hexagon does. So again, if I draw my regular hexagon, and then I draw in my apothem and my radius, all the angles of a regular hexagon are equal to 120 degrees, so now the 60 degrees is at the bottom, and then the 30 degrees is at the top. So keep that in mind. There are those special right triangles when we draw the apothem and the radius of those regular polygons.